Hello friends, welcome back to my channel. I am Dhanvin Sitpura and today we are going to perform the experiment of determination of focal length of concave mirror. Now before getting on with the experiment, let us understand some key terms which will be helpful to us in the experiment. First of all, let us understand the kinds of images. So there are two kinds of images, real and virtual image. Now the real image is one in which light rays actually reflect and arrive at the location of the image. Such kind of image is formed in front of the mirror and can be captured on the screen. Second type we have is virtual image. In virtual images, light rays do not actually arrive at the location of the image. Such images are formed behind the mirror and cannot be captured on the screen. Example is image formed by a plane mirror. Now let us understand some key definitions. First definition we have is the spherical mirror. The spherical mirror is a piece cut out of a hollow sphere of glass, as you can see, whose either of the side is made reflecting. Here one side is the reflecting side, which is reflective surface, as you can see, and one side is polished surface, which is harder painted surface. Light always comes from the left side of the mirror, as you can see. This here is the aperture. Aperture is the effective diameter of the light reflecting area of the mirror. Now this is the pole. Pole is the geometric center of the light reflecting area of the mirror. This is the center of curvature. It is denoted by C. It is the center of the hollow sphere of glass of which the spherical mirror is also a part. This line is called principal axis. It is the line joining the pole and the center of curvature. Now when light rays close and parallel to principal axis are incident on a spherical mirror, then after reflection they seem to pass from a point on the principal axis. This point is called the principal focus. Now the distance between pole and the focus is called the focal length. And the distance between the pole and the center of curvature is called the radius of curvature. And the radius of curvature is the radius of the hollow sphere of glass. And the radius of curvature is always twice of the focal length. As you can see, radius of curvature is equal to 2f, where focal length is equal to f. Now we move on to the next. So, on the basis of position of object, there are 6 cases of image formation in concave mirror. Here we have the 6 possible cases. So here we go with the first case. In the first case, object is between P and F. When the object is between P and F, we will get a virtual and erect image behind the mirror and the image will be enlarged. In the second case, object will be at F. When the object will be at F, we will get real and inverted image formed at infinity and the image will be highly enlarged. When object is between C and F, we will get real and inverted image beyond C and it will be of enlarged size. When object is kept at C, that is the center of curvature, we will get a real and inverted image at C and the image will be of same size as the object. When object is kept beyond C, we will get a real and inverted image between F and C and it will be diminished. Now when object is kept at infinity, we will get a point size image at F and it will be real and inverted. Now let us take a look at the case when object is at infinity and the incident rays are parallel to principal axis. So here we have our spherical mirror, the pole, principal axis, the center of curvature, and here we have the object. Now here you can see the two incident rays which are parallel to principal axis, and after reflection they seem to meet at a point focus. So in this case we will obtain an point size image at focus. Let us look at the second case when object is kept at infinity only but the incident rays are not parallel to principal axis. The spherical mirror, the pole, principal axis, center of curvature and the object. Here we have the two incident rays and you can see that they are not parallel to the principal axis. These reflecting rays, as you can see, also seem to meet at a point which is focus. And we will obtain a real and inverted image, but here the image you can see is not point size, it is diminished. Okay, so now let's do the practical of determination of focal length of a concave mirror. So the materials required are a concave mirror which is fixed on a stand, a paper with centimeter marks on it, a screen to obtain an image, and the object which is at a great distance which is unknown to us. So we assume that the object is kept at infinity. So now we know that when an object is placed at infinity, then the image is formed at focus, and so we can determine the focal length of a concave mirror. So now let's experiment it practically. Here I have kept the mirror at 25 centimeters. You can see that image is not at all formed. Now we'll push the mirror closer. You can see that image is starting to get formed. It's getting clearer, clearer, clearer. Up to some point over here it is clearer. Now it starts getting blurred. So our focal length should be between 15 centimeter and 18 centimeter. It's again starting to get clearer. And now at this point you can see that the balconies and the room and balconies and all that are the most clear. When I compare to this point, they are very less clear, and also when I compare to this point, they are very less clear. They are most clearer at this point, which is, let me mark it, this point is over here. Now let me remove the mirror and check. So this point, as you can see, I am getting is at 17 centimeter. So the focal length of this concave mirror is 17 centimeter. Thank you.